Hi, can you hear me, guys? Can you hear me? Can you hear me? Just confirm me that whether you can hear me.
Yes, sir.
Okay. So there are somebody who has joining to the class like after 1 million of years later. By the way, did you try the worksheet that I sent you? ඔයාලා try කරාද? මම යපු worksheet එක. That's the final one. And the very last episode of this series. Sehat. ඔයාට අවුරුදු ගන්නට පස්සේනේ. ඔයාලා අමතක වුණාද ඔයාට අවුරුදු ගන්නට පස්සේ? මම net මිට කිව්වේ net මිට අවුරුදු ගන්නට පස්සේ නෙන්නේ. දැන් දැක්කවත් ඉන්නවා. Okay, just give me a 1 minute. Okay, so we have completed what all of Newton's laws of motion, including Newton's first law, Newton's second law, and Newton's third law. All done. All done. So we have to do very simple things. Body දේවල් ටිකක් තියනවා කරන්න. Nothing really deeper. There are some simple and very small things to be done. So majority of the Newton's law of the motion is done, and we just have to practice all of these questions. And there is one last thing I have to teach you, but actually this stuff comes in under something called simple harmonic motion. Right? In the beginning of the third lesson. But some other teachers used to teach this part in this here and again in there. So I have no option. So I also have to do it now and later. Right? Do it right now and later. So now today I'm going to give you some kind of brief explanation only, brief introduction only. But in other days, I'm going to teach you this bit in detail. Right? In detail. So today, so very small part, really small part. So put a topic that forces in stretched strings. Forces in strings. A string, it may have kind of natural length like this. The natural length, L. Right? By putting an external force, right? By doing what? Applying some external force that of F here. What you can do? You can just extend it to a new length of what? This much. That is some delta x. Distance is some delta x. F delta x. Okay. Extension is kind of delta x. The force you apply here. At the beginning, what is the force? At the beginning, the force is 0. At the end, it develops to some force of F. The spring එකක් එහෙම දැකලා තියෙනවද ළමයි? යනවා. Springs. So body pan වලක් තියෙනවා. Body pan. When you press the stuff, it gets compressed, and you write. Once you have written, you have to just get it rid of. Then you press again, it just comes out. There is a very small spring. දැකලා තියෙනවනේ? හවුද නැද්ද? Yes. All right. I don't have a spring now, but I have a very big, strong catapult. See? At the beginning, the length, it has a length of what? Natural length, that is capital L. Now I am going to apply a force, but still no force applied. It is still 0. Like this, the force is 0. Now I am going to apply some force. Now I apply the force. Now I apply even bigger force. Even bigger force, I am going to release. You will hear the monstrous noise of this one. See, it's really powerful. So actually, there is a certain coconut land in front of my house. It's like a very big one. This is a Daras product. So I ordered, and I wanted to check, and I put a stone and stretched and threw it. You wouldn't believe it. It actually went past the vicinity of my vision. I'm pretty sure it went across the land. Then it's that much of really powerful, right? That's the mechanism of a spring. So good demonstration it is here. So the natural length again, L. Now there is no force, right? Actually, the force is 0, right? At the natural length. When I apply a force, bit is extended. That is the force is called as delta x, distance. And I keep stretching and stretching and stretching. When I keep stretching, it needs more force. So you can demonstrate this using a simple rubber band. Put one rubber band, one end of the rubber band to this finger and to the other finger. Try to extend. When you are trying, you will feel that your fingers getting the force, feeling the force. If you have used big rubber bands, not the small one. So now I can feel the force. When I try just drag, it just starts just a force, simple force. When I drag it more, it will spend more energy, more force, more force, more force. Now actually my hands are just kind of swearing, right? The maximum force is loaded. Can you understand? That's how you can just load a spring with the force. Can you just understand the mechanism of loading a spring? Yes or no? This is the very last part of the force that I have to teach. I need you to give you some good understanding because the boys know this one. But about girls, I'm in a doubt. Many of the girls, they don't have tried even. And then okay, there was a new girl, Akila Hussein. Hussein, Akila, can you hear me? If you can't speak up, at least text. Akila, if you can speak, just speak. That's good. Aslam, not Hussein.
I can
Okay.
hear you, sir.
Okay, Akila, have you finished this lesson, Newton's laws of motion thingy, before somewhere?
I have done it in school, but not properly.
Not properly. So you might find this is really difficult in this class because actually we have end this lesson. This is kind of very last tail end lesson. Now I'm going to start. That's called the forces in the string. In your tuition classes, haven't you ever done this Newton's laws of motion before?
We did,
Oh,
yeah.
okay. So you have kind of idea and
Yeah.
how to apply at least like Newton's second law, like F equals ma at least. That's
Yeah.
the least requirement. Okay, that's good. So otherwise you will find this one as a really difficult task. Okay. By the way, this is how you load the spring. See that again, natural length. There is no force. Once you extend, there is a force, all due to this extension. Okay. Now write, a spring can extend. A spring can extend or compress. I can't show the compression here because this is not a spring, but in a real spring, I can compress as well as extend. Like this, a spring can get extended or compressed by applying what? An external force. An external force. And the spring generates a restoring force. What? Spring generates a restoring force. What is it known as the restoring force? That means the force generated in the other direction. So that is what the FR actually the restoring force. Right? හරි. ඔක හොඳට තේරෙනවා ළමයි. මෙම අදිද්දී මගේ අත, see my hand gets the force in the other direction because I'm extending in this direction and the spring, this is not a spring, but this rubber band is trying to pull my hand towards itself. That's why it's called restoring force in the opposite direction. Right? Write this in a new line. The amount of force is directly proportional to the extension or the compression. Of the spring. Extension or the compression of the spring. Right. It's going to be the very last part now. Now this can also be a compression. This is what the natural length I'm going to extend. Right here. Now see, I apply a force that is into. Previously I dragged. Here, this one, I'm going to push. So this extension is right of a delta x, which is into. So now draw all of these three figures. Quickly into your No, 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 no. Extension is not similar to the refraction of light. In the refraction light, we used to call that the sin I and sin R series. This one is a completely different thing. This is completely a different thing. Okay, done. Normally, have you finished this one? Because I need to erase this level. Okay, I'll keep it. But I just need to know whether you have completed this one. Did you complete drawing this one? එක්කෙනෙක්වත් නැද්ද? Done. Okay. Others? Okay, good. Now I told you the force is directly proportional to the extension. Here, the force is directly proportional to the extension. At the beginning, the force was 0. At this point, it is F. So, even for the compression, that's the same. So, somehow, it is directly proportional to the extension of X. Okay. Now, have a good look at. So, what can I do for this extension? So, there is a proportionality sign. I told you a mathematical method to apply to here. What is that mathematical method that you can do to get it done? What is the mathematical step you can go for? I taught you in the second week of this class. You can put something. What is that specific thing to remove this proportionality sign? Can't you remember? Lamai, hi. Can't you remember? Very bad. Yes, Sydney is a really good girl. So you can put a proportionality constant. What is it? A proportionality constant here. This is what your constant that you can put kx. So to remove this proportionality and make it an equation, you have to put a proportionality constant, and I have to put another important point here. That is the negative sign. You might be worrying why it is negative. Why it is negative? Okay. I told you one thing. What? It is a restoring force. Restoring means once you release, it goes back. See? Restore means that. Restoring. That means it is going to get back to original position. So have a good look at. Once I pull this, what happens? This generates a force against the direction of extension or the direction of the compression. This is where the direction of extension, but the force generates always in the opposite direction. Right? In this case, the restoring force, this is the applying force, external force. This is what the restoring force in the opposite direction, Fr. Always opposite direction of what we are doing on the spring. Whether it is compressing, the spring tries to pull it apart. When we extend the spring tries to pull the things back. Harine? So that's why the negative sign stands for the force is applied against the direction of what? Extension. Mark it. Copy this and write the reason quickly. Okay, I will check your message, Netmi. Okay. Now write the meaning of this. What is F? F is the force built on the in spring, or restoring force. You can write restoring force in the spring, or the force built in the spring is force. Last one is what? X. X is what? The extension / compression of the spring. Extension / compression in the spring. Open a bracket and write change of length. Somehow it's going to be change of length. Change of length. More importantly, what is K? What is K? K is what? K is what? Spring constant. What is it? Spring constant. Write it. So what is the unit of spring constant? Your first lesson. Your knowledge about the springs. Find out the units of the spring constant by yourself. Unit. What is the unit? How to find? Force over extension. Try to find and tell me. Units. Oh, can't you find the units? Units of K. Force over extension. Quickly, tell me. Yeah, good. Newtons per meter. Really good. Nm minus 1. N slash m. Okay. It's not a dimensionless. No, it's not a dimensionless. It's not a dimension. Because this one is Newton, this one is meter. So your answer is become Nm minus 1. So write the definition of spring constant even. Now I'm going to erase this one. No need. Now let's write the definition of this one. What is the definition? The force required to extend or / compress a spring by a unit length. What? So I'm pretty sure I have to go to my virtual board to explain this one because In here, my capacities are very limited. So I will show you much better way of how to extend it by a unit length. So the real board things are over. Now I'm going to move to virtual board pack. Okay. Okay, guys. Let's then move. Okay. Just hold on for 1 minute. Okay, I will repeat the sentence. So give me a 1 second. Right. Okay, let me explain you that. This is how a spring with its natural length, right? I'm going to explain all the things right back. When you apply a force of 0, it is remaining on the length of capital L. Sydney, you wanted me to explain that the last line of the definition of spring constant. So if you want to just write it, the force requires to extend a spring, extend / compress a spring by a unit length. Okay. Now I am going to tell you what is this unit length all about. That's really important. Okay, have a really good look at. This is what the natural length scenario. Now it has extended by a length of delta x because of this external force of F. F equals to some force of F Newton. Right? Akila Hussein, are you familiar with this thing? Because my students are really familiar with this one, and this board is more powerful tool than the real board. I actually appear in the first few minutes in the real board because in the real board, my capacities are really limited. You will see in the question discussion, this board is a really powerful, 100 times powerful tool than a real board. Only thing is that you can't see me. It's not important because the only thing you need to have it is to get some clear understanding of the forces and how the behaviors. Because in this board, I can use multiple colors, multiple shapes, and everything with the angles. So even with the devices like this and the applications like so, when I measure certain angle, I can turn and show you the angle and everything. So this one is a really powerful tool. I don't know whether you have seen this thingy or not, because some other teachers don't use, some only very rare people use this one. Have you ever been in this type of virtual board class before? Akila Aslam?
Yes, sir.
Okay, then you are familiar with this one. Good.
Yeah.
Okay. Right. This is what the amount of force. Now this is the extension. From this one, I wrote an equation F equals to minus kx. The negative thing is because of the force is always applied in the opposite direction. When I try to pull this to here, but the spring generates a certain force always inside. So somehow, what is that unit length? Okay, now it's going to be the most important thing to understand. In MCQs, you find similar questions like this. And I know
everybody gets wind up with this one. No, I'm not going to use a spring. Now I'm going to use something else. Okay, this is what the natural length of something. This is what the natural length of something. Natural length, L. Okay, right. I'm going to apply the force is 0 and I need to extend this by need to extend this by unit length. Okay, unit length. Okay, Lamai. What is this mean? Unit length? Huh? Can you interpret what is the meaning of this unit length, man? A unit length. What the heck is that? A unit length. Unit length. Why? Why do we call it a unit length? Can anybody tell me the meaning of unit length? Ramaine, I need you to tell me the meaning of unit length, please. Unit length means, okay, what is the unit of measurement of length? Unit of measurement is meter. So unit length is what? 1 meter. Whenever you hear unit something, that means one of that. Okay, unit area. What does it mean as a unit area? An extra question. Area, unit area. That means 1 square meter, right? Unit temperature. What is it? 1 degree Kelvin. Unit mass. Unit mass. What is it? Unit mass. 1 kg. Lamai. When it say unit, always you need to take one of these. Okay. Let me erase these ones. It's like a nostalgic thingy. All lessons. Okay. Extend by what? Extend by 1 meter. Right. Now let me do that. I'm going to copy this one again here. This is what the length it had. Now I have to extend this by a unit length. Let me show you the unit length thing from here. Okay, this is what the unit length. It had the length of what? It had the length of L. Now you got extend it by, what is the extension now? What is the new extension? 1 meter. You extend that spring to 1 meter more. It had the length. Now the total length is what? L plus 1 meter. Can you understand now? Is there anybody who can't understand this? Is there anybody that who can't understand this? Because different people have different level of understanding of what? Spatial recognition. සමහරුන්ට space එක හරියට තේරෙන්නේ නැහැ. There are different people, they can't understand the space and behavior. I'll give you 20 seconds. If you don't understand this, tell me. Because when you don't know the real reason behind this, you won't be able to deal with. Now, 10 seconds more. Okay, finally, it seems to be that everybody understands this. Right, okay. Now I am going to ask you a very comprehensive question. Copy this one. Copy this one if you want. If you want, copy this one. The maximum allocation of time is 30 seconds to copy this. Ten seconds more. An important thing missed here. At this moment, the force is equals to F. Right. Now tell me, with your proper understanding, this is one spring, this is another spring, right? I need this, I mark this like A and this one as B. Okay. Which one has the highest spring constant? When all the other aspects are same but apart from length. That means both are made out of the same material, same cross-sectional area, everything is same, but the lengths are two different. Which one has the highest spring constant? It is like Ka here. In this one, it is Kb. Which one is the greatest? Ka or Kb? Okay. I will write two things. I will write, three possibilities. Ka equals to Kb. This is one possibility. The other one is Ka is greater than of Kb. The last thing is A is smaller than of Kb. Now, out of these three answers, which one is going to be your answer? I'll get this one as X, this one as Y, and this one as Z. Now tell me your answer. X, Y, or Z? I'm sure you will get different answers. Different people say different answers. Okay. Two people say, okay. Amma, I'm getting the same answer repeating. Okay. Wow. Same answer repeating. Okay. Yeah. Two different answers too. Wow. Others. Everybody. I need everybody's comment. Now three different answers. Olamai. There are some other people. They don't. Okay. Four different answers now. Enough. I know you guys don't respond. Right. Those who said the answer Y, right. Some other people thought because it's the same material, same other things, regardless of the length, they have the same spring constant. Frankly speaking, I thought the same way when I was in my A-level class. I thought the same way. It's the same material, same cross section. So the length is something irrelevant. That's how I thought. But you guys are brilliant, or by mistake, I don't know. Brilliant or by mistake, you choose the answer as Y. Actually, it is Y. I will tell you the reason. I will tell you the reason. Have a good look at here. I am going to get the extension as in black color. Okay, this is what my extension of 1 meter. The same 1 meter is going to apply to the other one. In which one you need more force to extend? In which one you need more force to extend? In which one you need more force to extend? So that's the logic it's going to be now. A, because why? A. Because it's naturally really short, you have to make it extend by 1 meter. So the longer one you can easily extend, but the shorter one is really difficult to extend by another 1 meter. Right? So the FA is greater than of FB. So here the inference is FA is greater than of FB. So you will know that another thing, F equals to K equals to force over X. Extension is the same because why? It is 1 meter. It's common for both. Now see here, when FA is greater, KA also going to be greater. When FB is lower, see? So the KB is also going to be lower. Understand? Can you understand? Because the extension is common for both. තේරුණාද මන්ද? Really good. Okay, let's move on to the worksheet that I sent you today and discuss. This is the final day of force, and in the next week, we are going to have a really big kickstart to what? Big kickstart to a new lesson called momentum. Momentum. When you know really well in what forces, when you are really good at momentum and the law of conservation of energy and momentum, you are unstoppable. So to spend these 4 weeks, upcoming 4 weeks, maximum on physics, with this will determine your entire journey of physics life, physics subject. Because even Einstein's what? Theory of relativity and everything, including what? Modern physics. We are still in classical physics. In university, you will learn the modern physics. Even the modern physics, the foundation is force, energy, and what? Momentum and power. Okay, so spend next 4 weeks extremely wisely. Sorry, don't miss out any class. If you miss out the class, watch the video at least 2 times. Right? Okay, today I am going to now start up that lesson, finalization of the post-final test. I think everybody got the news. Right. Let's start. This one. Okay. I will give you like, yeah, 15 minutes for the first 10 MCQs. Right? 15 minutes for the first 10 MCQs. Let's try. First, start the first 10 MCQs quickly. Okay, I will turn on the timer. Wait, I'll turn on the timer. Okay, your timing begin now. And you have to send me your answers at the end. Again, answer numbers now. As an example, A for 1. It's not the answer, but I'm telling you like it's A for 1, like that. Okay, start. Okay, now I'm going to begin the discussion. Please send me your answers. I will give you like 1 minute for you to type and send me the answers. In WhatsApp, those who have the phone with you, write the answers in a paper, like 1A, 2B, like this, and send me the 10 answers quickly as a photo. Okay, Sehat sent me his answers. Anitla Mike. Okay, I am going to discuss anyhow. Okay, guys. You, Sudhasini, after the discussion, I will send you the tutor. Let me send me her answers. Devmini sent me. Amanda sent me. Okay. Mhm. Okay, good, good. Hirasa sent me. And the new one, who is that? Her name? Akila. No sound from you. Akila. Akila. Did you do or not? So you didn't send me the answers in the Zoom chat too. Still doing. No problem. The amount you have done, like if you have only done 5 questions, send me the answers for those 5. That's it. Gayashi also sent me a one. Gayashi. 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 Can you speak up, Gayashi, for a while? Gayashi. Gayashi. Hello, Gayashi. At least send me a message if you can speak now. Gayashi. Gayashi. Okay. Do you know the meaning of your name? Huh? So when we detach your name, it looks like the meaning is she is Gaya. Isn't that? When we detach your name, it looks like she is Gaya. Imagine if your name was like Kausi. What would it mean? If there is somebody called Kausi, what is it going to be the meaning? Guys, tell me, what is it going to be the meaning? If somebody is Kausi. Ah, yes, she is a cow. But fortunately, this one is Gayasi, then it just simplified like she is Gaya. Amanda, තමයි phone වෙලා තියෙන්නේ, your friend. Now you can call her even she's cow. Doesn't matter. Okay. Amanda, actually, this is a trailer. The actual fighting session is coming after you, not actually on Gashi. This is a trailer I just saw you. Okay, let's pay the attention to the discussion of the question. After the discussion, I will send you at any time the biggest ever biting session to you. Today, it's going to be the biting day. After 3 weeks, 3 to 4 weeks, I didn't do anything because of the tension of the Newton's laws. I had to finish it. Now finished. Now I'm going to give you a bite. You will see how it is. Okay. A ball of mass M is suspended from 2 strings. One tension is here, the other tension is here, like strings with unequal length as shown above. The magnitudes of the tensions T1 and T2 in the string must satisfy the following relationship, right? The following relationship. Okay. Have a really good look at it. Mg is downward. So there is a force of T1 and there is a force of T2, right? T1 and T2. So somebody sent me the answer like T1 plus T2. So let's pay attention to the answer. Let's pay attention to the answer. It's like this one. T1 and T2. T1 and T2 empty. It will be only for this diagram, not for here. So yeah, all the answers who supplied the answer like provided the answer like this one is not. Because why? This one is going to be what? T1 actually, if the angle is like here, theta 1 and theta 2 is going to be what? T1 cos theta 1. This one is going to be T2 cos theta 2. Not T1 equal and T1 equals to empty. It's wrong. Can you understand? It is not going to be applied. Now, if T1 and T2 equal, it is definitely not going to be the same thing. Because why? Have a really good look at here. I will go for some numerical answer. 20 and 30 degree. 20 root 3. And it is a 60-degree thing here. What is the force of T tension here when the force is like 100 Newton? 100 Newton downwards. So now it's a numerical answer, right? So what is the numerical is going to be? From the right hand side, 20 root 3 cos 30. The other one, T cos 60. And the downward force is 100 Newton. Have a good look at here. T cos 60 plus 20 root 3 times root 3 over 2 equals to 100 Newton. This is 10 and root 3 is going to be 3. For 60 is half plus 30 equals to 70. Sorry, 100. T over 2 equals to but 70. T equals 140 Newton. Can you see that? When the angle is greater, the force should be bigger to give the vertical component. Can you see that? When the angle is greater to the vertical, it has to provide a greater support to the vertical. Okay? Understand? So what is the answer is going to be? This angle is greater, so the force should definitely be greater one to support. So this T1 is greater than of T2. There another one? Understood? Okay. The question 2 and 3 based on this one, this inclined plane, a 2-kilogram block is slide down the 30-degree incline as shown in above with an acceleration of 2 ms minus 2 is downward acceleration. It is a downward acceleration along here. By the way, guys, am I lagging or something? Because I can see the activities I'm doing on the board later. Am I lagging? If I'm lagging, just instantly send me a message. Am I kind of lagging or something? Oh shit, why didn't you tell me? I could see the diagram I drew. It appears from the board like many millions of years later. Then I understood like there is a lagging. Please, if I'm lagging, just let me know. Give me a 1 minute. I will fix the network to the other network and quickly do it. Lamai, see the connection and is that better now? Because I changed to the one of the different network now. Better. Yeah. Everybody has some network connection issues. No? Then you can't judge whether it's my fault or your fault. No? Now let me draw something. It appears on the right time. Okay, yeah. Okay. ඔයාලට පොඩි හරි සැකයක් આવොත් මට කියන්න. Okay. Which of the force best represent the gravitational force W and the frictional force F and the normal force N? Okay, one thing, whether it is gravity, it should definitely downward. So you can, at the first impression, you can cancel off these y because the weight cannot be slanted. The weight of the object always downward. So you can instantly cancel off these two answers. Now you have 50-50 chance. If you even don't know the real answer, you have a great chance to find out the answer. This one also can be cancelled off because why? The normal reaction force is always what? Perpendicular to what? Perpendicular to the surface. Perpendicular to the surface. This one is not perpendicular. So the answer is D. හරි නේද? Understood? Now let's go for the third one. Which of the following correctly indicates the magnitude of the forces acting up and down the incline? Up. Okay. Now up and down. Down. Down, what is the force? mg sine 30. Up we have to find. What is mg sine 30? 2, 10, and sine 30 is like half. It is like what? 10 Newton down the plane. There's only one answer here. You don't want to worry about the others. It's the answer D. It's the answer D. But there is a big problem. Why? Have to worry. Why? We can get the answer like that. If the friction is not applied, that is true. This is to actually to do what? Trap you. This one is to trap. This is the what? Trap. Why? This is not a frictionless surface. It has some friction. So you can take this answer. It cannot be this one. Then there is a MCQ technique given. There is a MCQ technique. Right? There is an MCQ technique to get the answer at the first glance. Right? There is the MCQ technique to get the answer under your first glance. But I will tell you the workout method. There is an acceleration downward. What is the acceleration, Laman? The acceleration is 2 ms minus 2. That is the force applying downwards. That is the force applying downwards. So what is the force? F. Now you have to apply. M is there with the acceleration. Applying the Newton's second law of motion. F equals to ma. M is what? 2 and the acceleration is 2. Answer is 4 Newton. That is the answer. Right? That is the answer. So what is the other way? So the real way you can get, if the friction, if it was frictionless, it should be 10 Newton. It shouldn't be 0 because there is an acceleration. So an answer should be smaller than this. Only answer smaller than this is here. Answer is that one. Can you understand? Right? Can you understand? So it's a really simple thing. So answer is B because of this logic. Acceleration. The other one, you don't need to even worry about that. Why? Because no other answer is telling in the left hand side. Get the answer as B. Now the fourth one. Now let's move on to the fourth one. When the frictionless system above is accelerated by an applied force of the magnitude, the tension in the string between blocks are this one. Tension, how it is going to be. Now the force is this one. This is a really tricky one. I'll explain you at here now. Have a good look at this one. Is really essential to understand. Shapes. One is 2 kg, other one is 1 kg. Right. Have a good look at here. 2 kg, sorry, 1 kg, 2 kg. And the tension here, we don't know, but there is a force of F. Okay. It is a frictionless surface, no friction. So the entire force is applied on Newton's second law, F equals ma. Now, how to get the acceleration of the system? You can find out the acceleration of the system by F equal over m. So that is what F over 3 is the acceleration. Now only consider about this body only. The body over here, that is 1 kg, and the force is F here. The acceleration is the same acceleration you found. It is under the same acceleration. You just need to provide the force of tension. Actually, the force is tension to make this 1 kilogram accelerated under same acceleration. So what is it? F equals to ma. Here the m is 1. What is that acceleration factor? It is F over 3. The answer is just going to be what? F over 3 Newton. Understand or not? Answer is D. Is there anybody that who can't understand this? Please raise your hand if you can't. Please. Lamai, is there anybody that who can't understand this one? Please let me know. You know that I'm not telling your name. You don't know. Understand. I am not like that. Can you understand? Might be everybody got the answer. Hadn't had the time to check. But this is the way how to obtaining the answer. I'll give you like 10 seconds to copy this. Time is over. Fifth one. A ball, no, fourth one. Sorry, fifth one. A ball falls straight down the path, down through the air under the influence of gravity. There is a retarding force F on the ball with a magnitude of dV. Okay, something dV, where V is the speed of the ball, V is the positive constant. Okay. The weight is downward, mg, and there is a retarding force of what? Vv. And the velocity downward is here V. V is the speed, and B, the ball reaches to terminal velocity after time of t. The magnitude of acceleration at t equals half. Wow, that's a good question. You have to understand what is terminal velocity. Terminal velocity means the maximum possible velocity can reach. After that, it is going to fall under the same velocity. That means the acceleration becomes zero here. Right? Okay. You have to understand many things to do this one. At the moment of stopping, how about the acceleration? Weight is mg, right? Upward force is Vv. So you can find out the final velocity here as what? Mg over v. As the final most velocity. Right? Final most velocity. So it takes what? Time of t. Right? Takes time of t. So it asks you one thing. The magnitude of the acceleration of t half. Whether the acceleration increase, decrease, 10 ms minus 1 or 0. Actually, that means when the velocity increase, you can see the force, the resistive force increase. When the resistive force increase, the acceleration downward, what? Decrease is not going to increase. So the answer is what? Not increasing, it is going to decrease. Because why? As it fall downward, the velocity increases. When the velocity increase, resistive force increase. As the resistive force increase, what happens? The resultant force reduces. When the resultant force reduces, the acceleration reduces. This is a really good complicated question. If you don't understand, drop me a private message after this class. I will give you a voice message or just drawing PD to explain you if you don't understand this right now. Sorry. So this is all about that question. Let's move on to the other questions quickly. So in the A level, you will find certain questions like this. Your understanding is going to be everything. Okay, here, the block of W, weight W is pushed along. Its weight, not mass, pushed along a surface at a constant velocity here, V, by a force of F, which acts angle theta to the horizontal, as shown above. The normal force acts on the block by the surface has the magnitude. Okay, it's a really simple question. The normal force. What about the normal reaction force? In normal condition, in the regular standard condition, when you keep something on the flat surface without external forces, the mg apply downwards and the r applies upwards the normal reaction force. Normally, normal reaction force equals to mg. But here, there is a force. If you provide some external force to there, what happens? So the normal reaction force here is the weight minus your external force. That means normal reaction force is lower than what? Weight. Greater than W? No. Greater than 0, but less than W? Yes. Equals to W? No. 0? We don't know. So it is not flying, no, it's not flying. That means it's on touch with the stuff. It's definitely not going to be 0. Greater than 0, less than W, that is B. Right? Now, a uniform rope of 50 Newton hangs from a hook as shown above. The box of weight 100 Newton is hangs from the rope. What is the tension of the rope? Okay, that's a good question because this one is what? 100 Newton. Here, there is a 50 Newton of the weight, but rope itself. Now at the bottom, this is 100. I taught you this method because this one only experienced the weight of the box. This part experienced what? 100 plus this 50 together is 150. So what is it? No, not 75, not 100, not 1. So it varies from 100 Newton to 1 at the bottom and 150 at top. Answer is here. The very simple one. Now the 8th one. When an object of weight W is suspended from the center of mass plus the string as shown above. Okay, it's a massless string as shown above. Okay. The tension at any point of the spring is going to be the weight is here. Now let me draw this. Weight applies and there is an angle of theta, and the tension, I'm only going to take the tension of one string. This component is going to be T cos theta. This side you always also got T cos theta. So what is it? 2T cos theta equals to W. So what is W? So as the tension at any point is what? Tension is W over cos 2 cos theta. W over 2 cos theta is here. Answer is okay. Now the ninth one. A block of mass 3 meter can move without friction on a horizontal table. On a horizontal table. Okay, 3M without friction. This block is attached to another block of mass M by a cord passes over frictionless pulley as shown. If the masses of the cord and pulley are negligible, what is the magnitude of descendance of the descending block? Acceleration. That is the same acceleration in this one too. Why? It's connected by the string. Okay, I will firstly do in the long method. Only considering the masses. 3M. This is what? M. It's connected through this type of pulley. And the tension of the wire is going to be T throughout. I'm going to explain firstly in the standard method. Next I will tell you MCQ method. The force is what? Mg downward. There is no force, supporting force provided by this one. It is just going to get dragged It's like a trailer in a container. Engine is the one provide the force. This one is just getting dragged. But this one has an acceleration of a. This one has the acceleration of same way. Now let me just write an equation for this one. T is the only force 3a, because F equals, according to F equals ma, right? F is T, M is 3, and acceleration is a. Now for this one, there is a force couple here, right? One is the upward force T, the other one is the weight. Now I'm going to ask you a question: which force is greater? T is greater than of mg or mg is greater than of T? Which one is correct? Which one is correct? Lamai, let me know which one is correct. Quickly tell me. Mg, what? Huh? The greater one. Yes, mg is greater than of T, because that's why it is accelerating downwards. Now have a good look at, I can write an equation again. F equals ma. In the last week I taught you F is nothing other than what? The resultant. The resultant is mg minus T, because mg is the greater one. This is right, this is wrong. Equals to the force of mass of m and a. Okay, now I can plug this T to here using this equation. This is the long method. Mg minus 3a equals to 1 into a. This is 1a. Mg equals what? Mg equals to 4a. A equals to mg over 4. Long method. This is the long method. This is suitable for essays. Essays. Not for MCQ. Not for MCQ. MCQ वोल्ट हम खरीदने का हरी क्या था? Then let me teach you the MCQ technique. Okay, I'm not giving you time to write because I'm sending you the PDF of this all drawings later, once the class is over. Let me teach you the MCQ method. 3m and m. Acceleration is a. Okay. From my logic, I know only driving force is provided by this one. All these masses, all 4 masses are going to get dragged along by this force of mg. That's the driving force. I can directly apply to F equals to ma. What is my only driving force? This one, no other force. Mg equals to, what is the total mass? M from this one, M from this, 3m from this one. It is 4m. G cancel off. Sorry, ma here. A equals to what? Wait. Oh shit, wait. I made a mistake here. I should have write this like not 1 ma. M is gone, G over 4. So A equals to G over 4. Right? This is just M. I can't just cancel now. It's just M. And it is what? M G over 4. Okay? This is really simple. If you don't understand this MCQ technique, tell me again. This is the most essential part you have to understand. Triple star point. Very important. Tell me if you don't understand this MCQ technique. Please repeat it. Okay, I will repeat. I'll repeat. I will. Which one do you want me to repeat? The MCQ technique or the entire process? MCQ one. Okay, my dear. Have a good look at. The only driving force is, let me just go for the image here. It's really ugly. Okay, I'll go to the next page. Okay, let me draw a proper diagram. Proper one. This is a frictionless surface, right? This is a frictionless surface. There is a very big mass. It is a big but no contribution. It is like a married man and his wife is not doing any job. And he has a very big family, including him and his wife and his children and their parents and brothers, everybody in the family. Wow, very big family. But the only breadwinner is the guy, poor guy. If he's a billionaire, it doesn't matter. If he's just a normal dude, it does matter. Okay, now this is how it connected. The tension of this one is equally spread. So there is a mass here. It applies a force of mg downwards. There is a 3m mass, and it's going to get attracted towards here. And the acceleration of A, the same acceleration is here. What is the driving force? F equals to ma. F is what? The driving force or unbalanced force. We use known as unbalanced force. What force is this one? The unbalanced force. Mass is what? Total mass. Why can I add? Why can I add? Because mass is what? Scalar quantity. You always need to add and add and add and add. But force is a vector quantity. So you have to add as well as subtract and many processes. So here, what is the force? mg is the only driving force. What is the mass together? 4m. Why? M from here, 3m from here, all together 4m a. M and m cancel, so what is going to be the acceleration? G over 4 is my acceleration. I explain you that again for the one last time. Okay? I hope you might get the point now. Understood? Good. Athene? So the answer is this one. Now let me explain you the 10th question. A plane 5 meters in length and inclined at angle of 37 degrees as shown above. A block of weight 20 Newton is placed at the top of the plane and allowed to slide down. Okay, allowed to slide down. This has a weight of what? 30 Newton. Sorry, 20 Newton. Inclined plane. The magnitude of the normal force exerted on the block by the plane. Okay. The normal reaction force. Here, this is a really simple question. Huh? The normal reaction force. So, what is it going to be? According to there is an angle of 30. So, when you construct, this is going to be what? 20 cos 37. Is that greater than 20 Newton? Definitely no. Is that equal to 20 Newton? Also definitely no. It's not 0. Greater than 0, but less than 20. Answer is yes. This one, B. Now tell me your individually. How about your marks? 10 out of what? Sorry. What out of 10? What out of 10? Quickly. I will give you like 20 seconds to calculate your own marks. තමයි මට කියන්න ඩග්ගා කීයක් තියෙනවද කියලා. Okay. Devmini. Actually, in my class, equal best girl. Best girl is Devmi and Devmini, D1 and D2. Then I'm equally well. Oh. Okay. Okay. Wow. Sikandar Rasa. 8. Really good. Impressive. Okay. Anita, can tell me your marks quickly. Tulasni told. Okay. Yeah, you have to improve a lot. The last one should be okay. 5 is kind of okay. Okay. Others. හැමෝම කියන්න වගේ marks කීයද කියලා. 5 again. Just okay. Wow. Chalaka, you are a little bomb man. 8 out of 10. Really good. Okay. Okay. Your timing is really bad. You got 4 out of 6. That means your timing is really bad. In an exam, it's all about timing, my dear. Right? If you have a really good proper timing, you are gem. Then if you have a really bad timing, that means you are really bad actually. You know? So, okay. Bavidu didn't send me any answer. Madhuri didn't send me any answer. Chatumi kata කරලා වැඩක් නැහැ ඉතින් යා එන්නේ නැහැ answers. Sahas Sitmi Tarusi 4 answers. Let me check who last me sent. Virasa sent. Let me send. Sahas, sorry, Sehat, Gayasi, Chalaka send me answers. And Devmini and Akila. Sitmi, no answer yet. Bavindu, no answer yet. Madhuri, no answer yet. Namaini. Kiyak harida කියලා කියන්නකෝ. How many correct answers are there? උන්ට වැඩි තියෙනවා මම කෙලින්ම තත් දෙනවා. Very bad. Okay. චතුමිර විතරයි වතර පොඩි chance එකක් දෙන්නේ. Because that's a nature. අනිත් කට්ටිය එහෙම නෑනේ. Okay, Ramai, one thing I have to tell you. So, this is what the real color of physics. You will see more real colors. See, more and more real colors. We can't discuss all the questions today itself, right? We can't discuss all the questions today itself because we don't have much time. There are 50 questions. Neither. So, I will give you a certain special thing to you to do, right? I will mark few questions as the question numbers, right? I will just mark like, okay, I will not give many. I will just mark 10 questions. What? 10 cues from this cue, from that about you. Okay? Okay? So it's also added to the midweek worksheet. Midweek, it's the going parallel with the midweek worksheet. Akila might be worrying, what is that midweek worksheet? I'm normally sending a worksheet around Thursday to Friday for you to do as the midweek worksheet, extra worksheet. That's the most important thing in my class. So here I will mark 10 MCQs. You have to describe, not only to do, describe. Like, it's like a review. You have to write a review like I did here. I explained all of these questions to you. Like this, you have to write the description about these 10 special questions that I mark for your homework. You have to do it and describe each step as much as you can. Not like I say, long essay. And if you can send me voice messages, it's also going to be really good, right? I need both. I'm not telling for even the most, what is it called? Introvert, try to send me the voice message. If you can, it doesn't matter. But that's in practice in 2023 group, I normally ask them to review some question, review some theory, and send me a voice message. Now this is the start. Okay, it's like this. Writing, I need writings for these 10. Out of these, I will mark, you can choose any three, and send me smaller, like 1 minute, 2 minute explanation of one question, and such 3 voice messages for each selected questions. 3 question is up to you. You can choose any 3 and send me voice message. Understand? ඔය කිව්වේ මොකක්ද කියලා තේරුම් නැත්නම් ඒත් මට පුතා කරලා අහන්න. ළමයි, understand what I'm telling you? Because in A-level physics, if you don't do work, you won't get result. Yeah, you can speak in Singlish. It doesn't matter. Even in Sinhalese, it doesn't matter. You can speak in Sinhalese even. හරිද? මම මේ ක්ලාස් එකේදී මේ ඉංග්‍රීසි ටු ඉංග්‍රීසි කරන්නේ මොකද මේ ඉංග්‍රීසි මීඩියම් ක්ලාස් එකක් සිංහලෙන් කරලා ඉතින් වැඩක් නැති නිසා. Otherwise, you can speak in Sinhalese. මම ඔයාලට මේ නිකන් වෙලාවට මම කතා කරන්නේම සිංහලෙන් ලාමයි. නේ? ඒක ප්‍රශ්නයක් නෑ. So you can describe it in Sinhalese or English or Singlish. And I know Hindi even. If you know Hindi, you can describe the stuff in Hindi. आपको हिंदी में रिव्यू देना सकता है. ये वाला बॉल एक्सेलरेशन होता है. अन्य विचार किया गया है तो ये प्रश्न है. These are the only 3 languages I know. ඔය language තුනෙන් ඕනම එකකින් දාලා ගියා. Okay. Right. Good. Did you see the real color of these MCQ questions? There are 50 MCQs. There are 50 MCQs. Okay. Now I'm going to you to tell to do certain few MCQs here. Not all, because we have done many. Okay, this one I leave as for your homework thingy. I'm not going to do. Okay, this one is just, I just gave you today. We have to discuss it today itself. We're not talking about this projectile thingy, spring thing. I'm going to add that to the cart. Likes of online shopping. Add to cart. I'm adding this to cart. Added that to cart. Question number 24. 20, sorry, just 20. Okay, wait. I'm going to add many to like 5 such MCQs, not 10 today now. 5. And this one, 22. Also added to the cart. Online shopping. Daras එක එහෙම කරලා දෙවම තියෙනවා නේ add to cart, add to cart, add to cart. Now I'm adding. This one I leave for homework. Wow. Should be done here. Should be done here. Because I know my students are really good at graphs. That's why I'm adding it here. දන්නවනේ කොල්ලෝ ටික graph දැක්කම හරි ආසාවෙන් කරන්නේ කියලා. This is to be done here today. Here today. This one is also added to the card. Mm-mm. 35. Add to cart, add to cart. If you understand the concept, what I told you in that last question in the pulley system thingy, you can easily do this one. If you understand my technique, MCQ technique, let's try this. Okay, guys. Now I've added all to my card. Let me write the question numbers. 22. Okay, somewhere here. 22, 24, 33, 35, and 45. Other question numbers. Let me expand this. Oh, Sudarsini, I will send you the worksheet. Oh, Sudarsini, oh, Sudarsini is not in here. Might be she doesn't have the worksheet. She might get disappointed and gone. Okay, lagi lagi yang mana mana ada nih. Take a humble in the time. Now I'm going to give you standard timing. Actually, in the last time, but Akila, actually, for an MCQ, standard time allocation is 2 minutes. For the previous one, I should have actually given you 20 minutes. So you don't have much problem with your timing. But I gave you this standard, slower standard time because all the questions were not this hard. Now, in this one, all the questions are really hard. So that's why I'm giving you all 10 minutes standard timing. Okay, your time begins now. Do these questions 22, 24, 33, 35, and 45 quickly. Let me start discussion now. Okay, so a block of mass M is accelerated across rough surface by force of F, extended at an angle of phi with the horizontal as shown above. The additional force on the block extended by the surface is magnitude of F. What is the acceleration of the block? If the force is here, you should know the driving force here is what? Driving force here is F cos phi. So there is a friction when you draw the free body diagram here. Driving force is F cos phi and the frictional force is F. What is the resultant force? That the resultant force is F cos phi minus F. And we have to apply F equals to MA. F is what? F cos phi minus simple F equals to MA. Acceleration equals to what? F cos phi minus F over M. So the answer is here, D. Mark your answer. It's not a very complicated question. It looks hard only. Just look, not actually hard. Force is here, time is here. A block of mass 3 kg, initially at rest, is pulled along a frictionless horizontal surface with the force shown as a function of time in the above graph. The acceleration of the block is t equals to 2 is force is what? You have to use your ability of reading graphs. According to time max is 2. What is the force here? It is 4. At that moment, the block is 3 kg. Surface with the force. It's a very force. F equals to ma. So acceleration is not also a constant one. What is the force? It is 4. Mass is like 3. Acceleration is a. 4 with 3 ms minus 2. Answer is A here. Okay. Now the very next one. Two masses M1 and M2 are connected by a cord and arranged as shown in the diagram with M1 sliding along on the frictionless surface and M2 is hanging from the light frictionless pulley. What would be the mass of the falling mass M2 if both sliding mass M1 and tension T were known? Okay. It says the frictionless, you can use my technique. But what is the only driving force? Like only breadwinner in the family, if the husband. So it is what? M2G. What are the overall masses here? Overall mass is, the total mass is what? M1 plus M2 are the total mass. F equals to MA. What is F? M2G is the only driving force here, right? So, wait. Tensor, okay. So, M2G is the mass. So, all the answers included the T. So, we can't use that technique here. Okay, now it's like M2G, M2G is the force. What is the other one? M1 plus M2A. What do they ask? Mass M1, M2 are connected by, so sliding along frictionless, and M2 is hanging. You need to find out the mass of, what would be the mass of the falling mass? M2, you have to find out the mass of M2, okay? So M2 is what? M2 equals M plus M1 plus M2A over G, right? Here, we can't go along this one because here the mass is, we don't know. So technically I have to go to back to here. It is like M2G and the tension is upward. M1 is going to get accelerated. Overall acceleration is A. For this one, I can write it like M1 A equals to just T. Equation number 1. Here, M2G minus T equals to what? M2A. So here the tension factor, I can include it here with tension. M2A let me get tension from here. T equals to M2G plus M2A. M2 equals what? M2 times G plus A equals to T. G plus A equals to T. We know that T from here. G plus A. But all the answers are excluding the mass here. There is no way to include M1 to the, because M2G minus T equals to M2A. Here the T is like M1A is just equals to T because no friction. Once we substitute the tension gone, so this is the only answer we can get. So there is a problem with the answer. If I have to check my workings. That might be a problem with answers there. Now in the third one, here, the small box of mass m is placed on top of the larger box of mass 2m, as shown in the diagram at right. When the force of F is applied to the large box, both boxes accelerate to the right with the same acceleration. Acceleration is same, right? 2m the right and the force is applied to the box. If the coefficient of friction between all surfaces, here it is mu, here it is mu, what would be the force accelerating? The small mass. Okay, the small mass. Okay. Now for this one, whole box. Right? A large box, the two boxes accelerate with the same acceleration. Okay, I have to find out the acceleration here. Right. So how to find out the acceleration? F equals to m. What is my force? It is not just F. F minus frictional force equals to 3a. Acceleration is going to be, the frictional force is what? Frictional force is mu mg. M is all together. The frictional force alone is mu 3g. 3mg. Mu 3mg. Right? Mu 3mg. Now let me apply it to here. F minus mu 3mg. Mu 3mg equals to whole mass 3m 3ma. Is the acceleration? I can find out the acceleration only. Acceleration is F minus 3mg mu over m. Sorry, 3m. This is what my acceleration. Now I need to find out the minimum force required to drive this. What is that force? Under the same acceleration, the small mass to the small mass. The friction is the driving force now. So you have to provide the friction with the acceleration. F equals to mu. Mg is the friction here. And that's the acceleration force. F equals to ma. So to provide the same acceleration, what is the force? That's the mu mg. Right? So what is the minimum force you require? This is what the force you require. M and F 3mg mu mg over 3m. So m and m cancel off. This answer remaining there. Right? Because yeah, here when you cut down, F over 3 comes here, and this 3 and 3 cancel off. Mg mu. Answer is A. Can you understand? It's a multiple step question. If you didn't understand, just let me know. තේරුනේ නැත්තම් ළමයි කියන්න. ළමයි, if you couldn't understand, just let me know. Yeah. Why you say sir? Yes, sir. Sir. So what is it? You just say yes, sir. Yeah, that's why it includes here. Because of this friction, that's why it gets accelerated. That's why it gets accelerated. We count the acceleration because if there is no friction there, this would slide over. Mega pattern, it would just fall down. So there is a friction. Thanks to this friction, it gets accelerated. Friction is the one which provides this required force to get accelerated. Can you understand? Friction is the one which provides this force to get accelerated. Don't you understand? If there is no friction between these two, this block will go to right hand side, this will just fall off. So the force required is F equals to ma. We found the force now, acceleration. Now we just need to apply to F equals ma. Don't we have to use? Yeah, that's what I used here. See, F equals to ma. M is there. Acceleration we just found for the whole system. The whole system has the same acceleration as of the small block, bigger blocks, and all three together. So I go to apply this acceleration to here. This m and the m factor over here cancel out. I open up the bracket by just dividing both by the same f3 and got this answer. Is that confusing yet? Oh, but it good. Given three masses as shown in the diagram above, if the coefficient of kinetic friction between the large mass m2 and the table is mu, what would be the upward acceleration of the small mass m3? Okay. If the coefficient of kinetic friction between the large mass m2 and the table, the mass and the function of the friction of the cone fully are small enough to produce negligible effect on the system. That means the friction on the pulley and the mass and the light, they are just negligible. Let me copy the object here. It is M2. There is a force of tension here. It's like T1. That's the same tension here. That's going to be provided by this M3. T2. This M1G, M3G. So this is just going to get accelerated on M2A, and all this system is accelerating under the same acceleration. And since this one is accelerating to right, there is a friction. I will just mark it like this. Simple left to the left, to the left. Now I have to mark all the forces on the system. Now, let me consider all three objects separately. Right? Tension here for this mass F. T1 minus M1G equals to M1A. Number one. Here, for this one,
T2 is the T1, T2. T2 is the greatest force minus T1 equals to what? M2 A. Number 2. Wait. I forgot one thing here. T2 minus T1 minus friction equals to M2A. Right. For the last one, let me write it. M3G minus T equals to M3A. That's the last answer. Okay. T2, sorry. To now, I have to substitute my answers, all the answers to here. From this one, I can take the T1 out of it. T1 equals to M1A plus M1G. T2 equals to what? M2A plus frictional force plus T1. Okay. Now, oh wait. I can go for that in even smaller way. I can get T2 from this one. T2 equals M3A M3G plus M3A. So I can plug these two results to here. And we know frictional force is what? Frictional force is mu M2G. I can also plug this result to here and finally find out the result what I want. Okay. What is T1 here? For T2, I will add this result M3G plus M3A minus what is T1? M1A plus M1G. And the friction, what is it? Mu M2G equals to M2A. Right. I need to find out the acceleration factor here. The acceleration is equals to what? M3. Oh, I have to get all the acceleration factors to there. Okay. All the acceleration factors to there. M3G plus M1G minus mu M2G equals to M2A minus M3A minus, sorry, plus, one comes here, M1A. So M3G plus M1G minus mu M2G equals to A times M2 plus M1 minus M3. M3, so කොහරි වැරදීමක් වෙලා තියෙනවා. එතනක හරි පොඩි mistake එකක් ඇවිල්ලා තියෙනවා ළමයි. Where did I make the mistake? M3G as P2. Oh, There is the mistake here. That's the mistake. That is the mistake. Here, this one is also plus. Okay, A equals what? M3G plus M1G minus mu M2G over what? All mass together. M1, M2, M plus M3. This is what the answer. It's a very long process. It's a very long process, but it's such a nice MCQ. Such a nice MCQ, but with a very long process. I can get the G out, so I can also get the G out. When you get the G out, M3 minus U, you can't get G, U out. Your answer is B. The answer is B. Right? It's a very long process, but you have to apply the forces to each, and this is too long for an MCQ, but it includes all the details what you need. Okay. Shall we get an interval and come? Likes of 10 minutes? විනාඩි 10ක පොඩි interval එකක් කරන් ඉන්න. Guys, let me know. 10-minute interval. Okay. Let me, you can leave. Okay, let me, you can leave. Okay, let's get 10-minute interval. Today, I can't give you like 20-minute intervals because we have to discuss many questions today. Not just one and two. Other questions ඉන්නව තමයි ගොඩක් කට්ටිය වැඩි log වෙන්නේ නැත්තේ. පටන් ගද්දිම දෙන්නෙක් නැහැ. Two people are just absent today. And others also, they think questions, no, not theory, but questions are the most important. If you don't know how to handle questions, after the interval, let's discuss the essays. Okay, interval. 10 minutes. It's going to be the countdown now. 10 minutes. Interval. Hello, lamai. Interval is over. Are you there? Lamai, are you there? Lamai, interval is over. I don't know what's wrong with you guys today. More than half is missing now. More than half is missing now. Only let me has a real reason to leave around 10:50 because he has an online exam. All the others had no reason, but so if there was a theory, everybody remaining to the last minute. But this is question discussion. They think, I can watch the video. Actually, it will never give the same effect as if what you are when you are in a real class. So Lamai, always try to remain in the real class as much as you can while the question discussion, because these question discussions are really very badly important, right? Okay.
So let's start up with the first one. This one is a really easy one. Let's start up with the first question here. Because we have done many such questions in the MCQ section. So this is almost similar one, like of the MCQs. Let's start off with this one. And I'll give you a couple of questions. This one and another one. Eight. The extension of that question. This one is like of an extension of the same question. So question number 1 and question number 5 are going to be your first assignment. Question number 1 and question number 5 are going to be your first assignment. So I will give you like a time of what? 12 minutes. 12 minutes for these two questions, question number 1 and question number 5. Your timer mix now. Quickly start doing. Okay, Lamai. This is going to be the lowest student count in a day. Do I? So I decided not to give you this type of paper discussion anymore. හරියන්නේ නැහැ. මම තාම තියරි එකක් අන්තිම පැය භාගයේ ගහක තියන්න ඕනේ. නැත්නම් මොකද නැතුව. So even for paper discussion in the next classes, I will add but last hour theory. Otherwise, I can't retain you guys in the class. Then I'm ready. Two guide rails for the elevators on above each exerts a constant friction force of 100 newtons on the elevator car when the elevator car is moving upwards with an acceleration of 2 meters per second. The acceleration is 2 ms minus 2. The pulley has negligible friction. Now friction you can and the mass. This one you don't want to worry about. On the and assume this. So drag the below, draw and label all the forces acting on the elevator car. Identify the source of each force. Right. Elevator on exerts constant friction 100 newton. There is 100 newton here. This one also exerts 100 newton. And there are exerted and the weight is like 4,000 newton because 400 kilogram. Also friction 100 newton and it's an acceleration of 2. And there is a tension in the string. These are the forces going to apply in there and calculate the tension in the cable lifting 400 kilogram elevator car during an upward acceleration of 2 ms minus 2. Okay. Now let me sort out these forces.
Altogether, what is it? 200 and 200 there, and 4,000. That means 4,200 Newton downward, and upward tension is there, and there is an acceleration of 2 ms minus 2. Okay. So what is the bigger force? T is greater than 4,200. That's why it's getting accelerated upward. T minus 4,200 equals to 400 times acceleration of 2. So 2 is like tension is 4,200 plus 800. So the tension force is going to be 5,000 Newton. Did you get this answer? Yes, did you get this answer? Did you get this answer, guys? Yes, good, great. Okay. Calculate the tension in the cable. We just found. Calculate the mass of the counterweight must have to raise the elevator car with an acceleration of 2 ms minus 2. Okay, this is what it's called the counterweight, right? Now the tension is here, counterweight is here. That is like mass of capital M. Okay, what is this tension in this side of the string? We just found that's the same tension applies here. Okay. I'm going to apply this one to here. Driving force is mg minus t equals to ma. Right? We know t and we know a, we know g. Only thing we don't know is m. T equals mg plus minus m a. So m can get out, and g minus a, m is what? T over g minus a. Now what is my t? We just found 5,000. And what is g? 10 minus 2, like 5,000 over 8. So 800, 800, that's about like 6,050 something, no? 650 again. No. Yeah, about 650 Newton. Did you get this value? Guys, did you get this answer? 650. Yes. It's not, it's 25. Yes, 25, not 50. Yeah, because the remaining 200 divided by, not by 40, 8, yeah, 625. Your answer is right. 625. Right. This is the extension of the same question. Three blocks of mass 1 kg, 2 kg, and 4 kg are connected by massless string, one of which passes over frictionless pulley with a negligible mass. As shown above, calculate each of the following.
Unnegligible mass XLS, the acceleration of 4 kg block. 4 kg විතරක් නෙමෙයි ළමයි මේ ඔක්කොම. So you can see that this is the greatest acceleration is towards the right hand side. From my technique, can you remember that technique? So find out the reaction resultant force. Resultant force is what? 4g minus 3g. This is what the driving force 4g. This is what this resistive force 3g. So what is the total mass here? Total mass is what is it called? Scalar quantity. So you can add them together. 7g. So g equals 7a. G equals to 7a. A equals to 10 over 7. G is 10. G equals 10. 10 over 7. ms minus 2. Okay. Did you get this answer? I did this in the simplest method. You can also do it in very hard method. Here I just found the driving force and subtracted it by the resistive force to apply to F equals mv. F is the resultant force. So resultant force is what? Driving force, and the resistive force equals to mv. Very simple. The tension in the string supporting 4 kg block. Okay. Only the 4 kg block. Here I can apply like 4g minus t equals to 4a. We just found t equals 4g minus 4a. T is going to be 40 minus 4 times 10 over 7. That means I can get it like 40. Yeah. 1 over 7 times 40. So 7 over 6 times 40 over 7. It's more like 240 over 7. Just keep it. Tension in the string connected to the 1 kg here. This tension. So again apply the same force. Now tension T2, I will get it like T2 minus 1g equals to 1a. So acceleration is one thing we know, and the T2 is like 1a plus 1g. So T2 is going to be equals to a we know now 10 over 7 plus 10, like 80 over 7 Newton. So this is how you have to get. So very simple method. It's a very simple method that you can apply. Wow, only 7 students remain. Okay. Now let's do the 7th one and finish the day for today. Otherwise, you are 7th එක හදලා. So I'll give you maximum like 6 minutes. Okay, your timer starts now.
6 minutes. So guys, how are you? The last question that I'm going to discuss today. A helicopter holding a 70-kilogram package is suspended from a rope 5 meters long, accelerated upwards at from 5 meter long, and a cable package suspended from a rope 5 meter long at a 5 ms minus 2. Neglect air resistance on the package. It is 70 kg. So that means on the diagram above, so low and level all the thing on the package. So that means here 700 Newton, like 70 G, I will multiply 70 G, and a force of tension upwards and upwards at the acceleration. So acceleration is not going to mark only these two. So but I just now like 5 and s minus 2 as the acceleration. Determine the tension of the stroke. So when you get it like this, T is greater than 70 G. So T minus 70 G equals to 70 A times 5. T equals 70 times 5 plus 70 times that 10, that 700 and 350, 1050 Newton speed. Did you get this answer right? Confirm me. When the upward velocity of the helicopter is some 30 meters per second, the rope is cut and the helicopter continues to accelerate upwards at 5 ms minus 2. Determine the distance between the helicopter. So when the velocity and the helicopter 30 meters per second, the rope is cut and the helicopter is continuing upward at 5 ms minus 2, and determine the distance between helicopter and the package 2 seconds after rope is cut. Okay, it's like a projectile motion. Now at this moment, it had initial distance of what? 5 meters. You have to from the helicopter. Now the helicopter is just accelerating upwards with 5 ms minus 2 and the initial velocity of 30 meters per second. So this one has only the initial velocity of 30 meters per second and then downward acceleration, which is G acting on this. So I can mark it like this one moves up with this distance of 5 plus some distance of T S helicopter, and the what is it? This one, that means the package moves kind of similar height, something that means I can get it like package. Okay, now your distance is going to be difference is going to be what? S helicopter plus 5 minus distance of the package. This is how you get the result. Okay, let's find. We just simply apply the what is it called? Motion equations in the projectile motion here. This one I can just with the initial velocity and acceleration is there. U is like 30 times 2 plus 1, 5 times 2 minus that plus that 5 initial distance minus of the package. What is our package?
and the ut is like 30 times 2 is there, but there is a negative factor 10 times because the acceleration is downward. Let's find out the distance here. This part can completely cut off because no effect. And it's like here 5 times 2 here and 10 plus 5 minus 20. There is a distance of minus 5. Minus 5 means from that position. From that position, it made some 5 meter downward. So the distance is some 5 meters from the position. From helicopter, there is a 5 meter distance already. So 5 plus this 5, total spacing is what? 10 meters. There is a 10 meter gap between the helicopter and the package now. Understand? There is a total distance of 5 meters from helicopter and the package now. Got the point, guys? Understood? Oh, sorry. I made a terrible mistake here. Sorry. No. I made a mistake. Terrible mistake here. I forgot to put the bracket to here. So it's going to be a positive one. That's why I was wondering how come I get small answer. 15 plus 20. So the result is going to be some 35 meters now. The gap increases to some 35 meters from there. Understand? Can you understand that, guys? Yeah, okay. So let's wind up the class for today. But before, I have to ask you, I have no intention of doing any more questions because I just give you like the homework because we have a big amount of questions here, and the midweek worksheet will be comprised of many big questions. And as I told you, I need few things, but you have to describe almost like you have to describe and review what 10 MCQ. Out of those 10, 3 MCQs, I will give it like voice message. So if you are not a proper introvert, and if you are really embarrassed of doing that, ashamed of doing that, you have some kind of what freedom to not to do that. It is no problem. But if you can manage, so please do it. And the other is some including at least like 2 essay questions from this one. I will just ask you to just do, right? So this is going to be something you have to do addition to the midweek worksheet. හරි. දැන් අර 23 ළමයින්ට වගේම ඔයාලට මම පටන් ගන්නවා voice message වලින් ගන්න වැඩි. කතා කරන්න පුළුවන් මේක. බැරි අයට ප්‍රශ්නයක් නැහැ. You can use your Sinhalese language or English language, whatever. Don't use Tamil because I don't know. Okay. By the way, I'm happy about you guys because at least some 7 students remaining at the end of the class. So this is like a bizarre experience for me because normally many guys remain in the class at the end, but here it's really, really bad. Okay, guys, God bless you. Bye. Class is over. God bless you.